In this video, I'll discuss support for asset transactions in DynamoDB. Then I'll use an example to walk you through the working of TransactWriteItems API. And I'll end this video with some best practices. For demo, I'll use the NoSQL workbench. DynamoDB transaction APIs are available for executing multiple all or nothing actions within and across tables with a single API. The operations can be carried out across multiple items in the tables. The item manipulation operation are applied to each of the items, and if all operations are successful, then the transaction is committed and the updated data is available in the items. In case there is a failure in one or more item operations, then the transaction is rolled back and the data for the items is the same as prior to the execution of the API. Although in this illustration I'm showing the transaction API getting executed against single table, DynamoDB transactional API can be applied across multiple tables as long as the tables are in the same region and they belong to the same AWS account. DynamoDB transactional APIs support two types of condition checks. First one is at the item level. It's available for the put, update, and delete item operations. You have already seen the condition expression for these operations in action in one of the earlier lessons. For transactional writes, there is a condition check at the transaction level. The idea is that if any of the conditions fail, the transaction is rolled back. The TransactWriteItems API groups up to 100 operations in a single unit of work. There are two keywords in this statement, unit of work, which means that all operations in the transaction are either committed or all operations are rolled back so that item data is in a state prior to the execution of the transaction. Let's talk about the four operations that are supported. You can have put, update, delete, and the fourth one is condition check operation. You already know about the first three operations, and I'll discuss the fourth one in a minute. The combined size of items in a transaction cannot exceed 4 MB, and a transaction cannot contain the same item in multiple operations. Recall that put, update, and delete operations can have a condition expression. If the condition expression evaluates to true, the item operation is successful. Otherwise, the item operation fails. If there is a failure of any of the item operation due to the condition expression, the entire transaction fails. Let me explain the condition check operation now. Think of the condition check operation as similar to condition expression that is applied at the transaction level instead of the item level. The condition check operation also requires a condition expression. The idea is that if the condition expression evaluates to false, then the entire transaction is rolled back or is not committed. The condition expression in the condition check operation must be applied to an item that is not getting manipulated by any other operation in the transaction. As an example, think of a bank account. Let's say you are adding a credit or debit transaction to the bank account. In the condition check operation, you will check if the bank account number exists or not. If it doesn't exist, then the transaction should fail. To demonstrate the working of TransactWriteItems, I'll use a model for flash sales discounts. An e-commerce vendor publishes a discount code that is available for a limited amount of time and in limited quantities. So what that means is that if the vendor publishes a code with, let's say, a count of 100, when a customer uses that discount code, the count for the discount code goes down by 1. So as soon as 100 customers have applied the discount code will become unavailable. This is the ERD for flash sale discounts. There are two types of discounts. The first type is a general discount, which is available to all customers. And then there is a loyalty discount. The loyalty discount is available only to the loyal customers. Each customer has a loyalty points balance, and the loyalty discount code have a minimum loyalty points condition, meaning that to become eligible for a loyalty discount, customer must have loyalty points greater than the minimum loyalty points needed for that discount. The attribute remaining holds the count for the discount code that are available to the customers. For the sake of simplicity, I am not showing the other attributes in the 3 entities that are part of this model. The model that I'm using for this walkthrough already has some sample data, and this is the aggregate view for that data. These are the standard discount code, these are the loyalty discount codes. The attribute remaining has the count for each of these discount codes. This is the customer information. Here you see the loyalty point balance for each of the customer. In this sample walkthrough, we will use discount code 100 for the customer with the ID John. Here is the business logic that we are going to implement using the TransactWriteItems. A customer can use discount code only once, and if the customer tries to reuse the discount code, the transaction should fail. There will be 2 operations that we are going to add to the transaction. First one is to decrease the discount code remaining count if the discount code is applied successfully. And the second operation will be to add an item indicating that customer has already availed the discount code. So we will use a put item with partition key equal to the customer identity and sort key equal to the discount code or discount identity. If the item exists, then the transaction should fail. The instructions and the model JSON that I'm using in this lesson are available under the transactions folder. The instructions for setting up the test environment are available in the readme.md file. We need to import the flash sale discounts model.json to the workbench and then commit it to the local DynamoDB. To run the API, you may use the CLI. The commands are available in readme.md file, or you can use the workbench. I will be using the workbench. I've already imported this model in my workbench environment. Open up the local DynamoDB environment, select the flash sales discount. Now we see all the data from the table. Click on expand operations, select transaction write items. At this point, we're ready to add our first action, which will be update item. Click on this plus button, select the table, which is flash sales discount. Partition key will be the discount code 100. And in the update expression, we will use the set. Provide the expression, select the attribute remaining, equal to, attribute type is number. Check this box for plus minus, select the operator decrement by 1. We also want to make sure that the remaining count is greater than 0. So for that, we're going to add a condition. In the condition, we will provide the name of the attribute remaining greater than attribute type number, and attribute value will be 0. So at this point, we have added one operation to update the count for the discount code 100. Let's add another action, which will be put item add, and the table name is flash sales discount. We will apply this discount for customer by the name John. Sort key will be the discount code, and we want to make sure that customer John has not used this discount code already. So put item should fail if a row with the partition key customer John and discount 100 already exists. And so the condition expression will be look for a sort key, attribute not exists. And what that means is that if the item with partition key cust hash John and discount hash 100 does not exist, then the put item should be successful. So now we are ready to run this command. The operation was successful. Let's check the remaining count for discount code. Discount 100, discount 100, run. And as expected, the count for discount 100 has gone down. We should also check if we have a row for customer John and discount 100, and as expected, we do see it. Now let's try to run the same transaction write again. This time it should fail, and the reason is because the row for customer John and discount 100 already exist. As a next step, I suggest that you try out 2 things. First, generate the code and look through the code to understand how the TransactWriteItems API is used in the code. Second thing is that I have used the workbench to demonstrate the working of this API. I suggest that you try out the same API from the AWS CLI. You'll find the CLI command in the readme.md file. So go ahead and try it out on your own. I'll see you in the next lesson. Let's go over some best practices. Use transactions only if needed, as there are performance and cost implications. Multiple transactions updating the same items simultaneously can cause conflicts that cancel the transactions. So avoid conflicts by way of appropriate table design. Avoid using transactions for bulk data uploads. Ensure that there is enough provision capacity, as transactions use up double the request units for reads and writes.